Hello and welcome to my math companion. In this video, I will be examining a second example involving solving quadratic equations by completing the square. So let's begin. This question tells us to solve 2x squared plus 12x plus 8 is equal to 0 by completing the square. In any quadratic equations problem, you must first write your equation in the form of ax squared plus bx plus c is equal to 0. And we see that our equation is already written in that form. So a is the coefficient of x squared and is thus 2, b is the coefficient of x which is 12, and c is our constant term which is 8. So next we will take this constant term of 8 to the right hand side of the equation by subtracting 8 on both sides, and this is an extremely important step in completing the square. If you're not sure of why we do this step, do watch our previous video on completing the square in which I have clearly explained the logic behind this step. So now we need a binomial squared on the left hand side of our equation, and this binomial will be in the form of x plus d whole square. And when we expand this binomial, we will get x squared plus 2dx plus d square. So this is the general form for any binomial the whole squared when you have the coefficient of x as 1. So the constant term in this case is d, but you could pick other letters such as a, b or c. So we see that if we are to have such a binomial whole squared on the left hand side of our equation, then we must have the x squared terms to be equal and the x terms to be equal. And by doing so, we will find the value of d, which will give us the value of d squared. So if we want our x squared terms to be equal, we must have their coefficients also to be equal. And we see that in our binomial expansion, the coefficient of x squared is 1, whereas in our equation it is 2, which means that we need to bring this coefficient of x squared to 1. And we will do this by dividing by 2 on both sides of the equation. And we could also revert this as dividing the entire equation by 2. It means the same thing as dividing 2 on both sides. So now, if we perform this operation, we will get 2x squared plus 12x whole divided by 2. We can separate these terms as 2x squared by 2 plus 12x by 2, and negative 8 divided by 2 is just negative 4. So 2x squared by 2 is x squared and 12x by 2 is 6x, so that will give us x squared plus 6x is equal to negative 4 as our new equation. So next we must equate our x terms. Since in our binomial expansion the only x term is 2dx, and in our equation the only x term is 6x, they must be equal. Now note that this x square cannot be considered an x term because it is an x square term, and x square and x are not the same. They are not like terms, which is why you cannot add x square to x. They are simply not like terms. They are considered different variables. So we must have 2dx equal to 6x, and now we can just cancel out x on both sides by dividing by x, and we'll get 6 to be equal to 2d. And now we have to isolate d, and we'll do that by dividing by 2 on both sides to get its coefficient to be 1, which means that d is equal to 3. So now, just like in the previous video, we will put this value of d back into our binomial, and this will give us x plus 3 the whole square, which is x squared plus 2 times 3 times x plus 3 square, which gives us x squared plus 6x plus 9. So now we have our desired binomial that must be squared, and that binomial is x plus 3. And this is our original equation of x squared plus 6x is equal to negative 4. And you may notice that if we just add this 9 to the left hand side of the equation, we would get x squared plus 6x plus 9, which we know to be x plus 3 whole square, the perfect square of a binomial. But remember, we must add 9 to the other side, that is the right hand side of the equation as well, otherwise it will not be an equation anymore. So we will add 9 to both sides, and on the left hand side we will get x squared plus 6x plus 9, which is our desired result, and on the right hand side we'll get negative 4 plus 9. So we can write x plus 3 the whole square on the left hand side, and the right hand side evaluates to 5. And now, just like what we did for the previous problem in the previous video, we will take the square root on both sides since x plus 3 is being squared. So taking the square root on both sides, we will get x plus 3 is equal to positive or negative square root of 5. And the square root of 5 cannot be simplified any further because 5 does not have any perfect squares as its factors. So now we must simply solve for x. And we see that 3 and x are on the same side of the equation, so we must take this 3 to the other side by subtracting 3 on both sides. So first we will take positive 5 and evaluate x for that value. And by subtracting 3 on both sides, we will find x to be root 5 minus 3, which is approximately negative 0.764. And again, note this approximation sign because root 5 is an irrational number and therefore you cannot calculate its perfect value or exact value. Next, we will take negative 5 on the right hand side and evaluate x. So doing the same thing, we will get x to be negative 5 minus 3 since we subtract 3 from both sides, and this will be approximately negative 5.234. So this means that x has two values which are root 5 minus 3 and negative root 5 minus 3. So that is how you solve a quadratic equation by completing the square. In the next video, I will be looking at an even more complex problem involving completing the square, so do join us in that video.